inverse trig functions continued, but we have a few questions from a handout that we recently did. Which question was it? Okay. Oh, all of them? Oh,
It's one when you once I see it.
once you see it, you'll okay. So just stop me whenever you remember or figure out what the question is. Okay. So inverse trig. Okay. So let's just kind of get into it. So I think last time, so we kind of mentioned something. Can I get a blank page? Yeah, let's do it like this. Let's just do insert, another slide. Yeah, that's fine. And then slide. So this is for some quick annotations. Actually, it's a little bit more my speed is this guy. Yeah. Y'all feeling any colors today? You feeling any colors? What color you feeling? I heard turquoise. Turquoise. Is turquoise green? Like that?
Sounds like a greenish blue.
Greenish blue. Let me see. Kind of like this one or that one. Okay, that'll work. Let me think about it. So okay, let's start with let's kind of recap when we talked about sine, right? So last time, if we look at the graph of sine of x, right? So if we it's throwing me up. So if we just let's do this really quick. And then if we're gonna do sine, say this was 1, say this was -1, say this was what, 90 degrees, 180, 270, 360. Is that okay so far? Say we're doing sine of x, right? This one. So if we're graphing sine by itself, where does sine start? Does it start in the middle or the top or the bottom? Sine starts at the middle, right? So if we were just graphing sine like normal, right? Sine starts here, and then we have our 5 key points. This is kind of reviewing a few different sections. So sine starts there at 90 degrees. What's the value of sine? 1, right? At 180, what's the value of sine? 0. And then at 270, and then at 360, we're back to. Can you tell me what the next one would be? Yeah, we'll go back to 1, right? So it continues that pattern. So the graph of sine is kind of like this, right? So now, and let's kind of go the other direction as well. A little bit. restriction on sine, so that way it'll pass the horizontal line test. So where do you think we do this? From where to where? So good old friend the train. So yeah. So notice we can draw a horizontal line and it touches it more than once. Remember we last time we did a restriction. Let's do like this, and it's maybe a little too big. That's fine. And then let's do this one. So we said let's restrict sine from here to here. Is that okay? So what was the restriction on the domain for sine? Oh, okay, there it is. Okay, so let's go back, I guess, here. Okay, so now if we consider sine of x, we said the domain last time we restricted it from -90 to 90, like that, right? And then what's the range for this restriction? Okay. So whenever I'm trying to figure out restrictions, I always look at that bold little S shape that you see. Because that to me that's clear. We see we're restricted from -90 to 90, and the range is -1 to 1. And then let's look at inverse sine of y. We'll do it like this, or maybe something a little different like this. So when we consider inverse sine of y, this is now our range, and this is our domain. Is this okay? And so there was a similar discussion for cosine and tangent, and then we kind of explored, different concepts with those. Is that okay with everybody so far? Okay, so I just wanted to kind of touch back on that. Let's kind of get into where we are today. Okay, I don't need the slide. Okay. So some objectives today, we want to find the exact value expressions, find the exact value of expressions involving inverse sine. I'm pretty sure the audio is not working. I just remembered something that I was forgetting. Let me do something really quick. Might have to. I think there might not be any audio. Ali Oxenfree, maybe. But let me do what I'm thinking about anyway. Forgot my microphone. Can somebody pull up the stream right now and tell me if you can hear the audio? Hello. The YouTube stream. I got the notification. But open it and see if you hear the audio. Hello. Come on. It's moving super slow today. Hello? Yeah. Okay, that looks good. So do you hear anything? Are you watching this? Anybody, you watching the stream? Yeah. Okay. All right. So it should be working now. I forgot to check that. Okay. So we'll do the best we can. So we're asked to find the exact value of expressions involving inverse sine, cosine. Did we not do this already? Exact values. Let's kind of keep going. Okay. So let's see. Find the exact value of sine of inverse tan of a third. Okay. So actually, I'm going to get a copy of this, and I'm going to go back to my other utility. Okay. So in this one, we're asked to find the exact. You can hear it now? Okay. It should come in. I don't know. I might just have to redo it if it's not working. You hear it now?
Yeah, it was just quiet.
Oh, okay. Has it been working from the beginning? Okay, it's a live stream, so yeah, we're okay. Okay, so we're gonna let that be. No. Okay. So we're asked to find the exact value of sine of inverse tan of a third. Let me see. So let's do paper. You like my grid paper. So we have sine of inverse tan of 1 by 3. Okay, so what were the restrictions for tan? Does anybody remember? Okay. So with a similar kind of logic, so if we consider tan of x, the domain of that went from negative 90 to 90 with parentheses, and the range went from, can somebody tell me the range for tan? There it is. So tan, because tan has a little S shape, right? It goes way down or way up. So the very bottom, negative infinity to infinity. So then when we consider inverse tan, let's just use this color. Inverse tan of, we'll say y. This is now our range. This is our domain. Okay? So now, since we're considering inverse tan of a third, is 1/3 inside the domain for inverse tan? So the domain for inverse tan is in green, and the domain for original tan is in black. So is that 1/3 inside the domain of inverse tan? So in other words, yeah. What's the domain of inverse tan on the screen? All right, domain on the bottom line. What's the domain of inverse tan? Okay. So is 1/3 inside that domain? Yes. So we can proceed. Remember, because we had to make sure that those numbers are in our domain. So okay. So now let's focus on this inverse tan of a third. So if we're saying inverse tan of a third, this is going to be equal to what? Some x. Again, this means tan of some x equals a third. Do we know tan of some angle to give us a third? Tan is, how can we find tan? What is tan? Tan is sine over cosine. Okay. So is there a sine of x over cosine of x that's equal to a third? Where could we possibly find something that might work here? The unit circle. Can you describe the unit circle to me quickly? What'd you say? Okay. What do you say? Okay, that sounds good though. Really quick. Let's review. So if we go like this, so this this is like let's go like this. This is our 45 degrees. This is our 60 degrees. This is our 90 degrees. This is our 30 degrees. This is our 0 degrees. And that's fine. And then we do blank set of fractions and parentheses for all of them. All the denominators are 2. So that's a 2, 2, 2, 2, 2, 2. How do we do the top? 1, 2, 3, 1, 2, 3. And then we take the without square root. Yeah, take the square root of all the top. Square root, square root, square root, square root. This is our cosine x. This is our sine of x. Okay, and then this one is 0, 1. This one is 1, 0. Okay, so that's the unit circle. So now, do we have a sine of an angle divided by a cosine of that same angle to give us a third? No? Not really? No? If there was a square root there, we might be in business. Okay. So let's do this real quick. Let me think about this. Okay, we have another solution. So now we tried unit circle. So what's another technique that we have for maybe finding an angle? What's another technique that we talked about? What was that first technique that we talked about? What'd you say? Pythagorean, right? So let's try that one. So notice how we tried one technique, it didn't work. So now we're going to back up. We're going to do inverse tan over third. Again, that equals some, you can call it x or you can call it theta. Basically, we're saying an angle. Okay, so now let's try this. Hang on. So if we just draw, what do we say, a right triangle? I'm just drawing a random right triangle. Okay. So say this was our theta. So tan of some angle is 1 over 3. So where does the 1 go? Where does the 3 go? What is how do we remember? SOHCAHTOA, right? So if we did SOHCAHTOA. So where does the 1 go? Where does the 3 go?
So 1 goes on the opposite side.
Opposite goes here.
3 goes on the
Adjacent. So what are we missing? The hypotenuse. How do we find that? Okay. That is fine. I'm going to do x squared plus y squared equals r squared. What you said is perfectly a-okay. Okay. Do we have our x? Or basically the square of the small sides, right? So we would say 3 squared plus 1 squared equals r squared. What is that? R squared equals what? What's 3 squared? What's plus 1 squared is 10, right? So r squared is 10. So then r should be what? Square root of 10. Okay. So what angle? Why did I do that? Oh. Okay, so now, we never really found an angle, right? But that blue part, and let me kind of highlight it like this. Again, this thing here, that blue part that I just highlighted with the moving part on the left, that's just an angle. So we found the hypotenuse here. We said the hypotenuse was the square root of 10. So even though we don't know the angle, we can actually proceed. So now that we found the missing part, the blue part here, I'll continue here. Now this becomes just sine of that angle. So now if we go back to our right triangle trigonometry, what's sine of that angle? We're right there. What's from SOHCAHTOA, what's sine?
Oh, opposite hypotenuse.
All right, so right here. So opposite over hypotenuse, so this should be 1 over the square root of 10. And then if we rationalize, root 10 over 10. Okay. I know there was a little bit, we had to pull out all our tricks, right? Because at first we tried to use the unit circle. I was thinking that it was on the unit circle, but then after we tried it, the unit circle had square root of 3 and we did not, so we couldn't use the unit circle. So then we had to try a different one. Another technique was the right triangle trigonometry. So we said that if inverse tan of a third is some angle, then that means tan of some angle equals a third. So then we use the whole right triangle trigonometry like you see in the blue on the right.
I just want to make sure I understand everything. So sine bracket 10 inverse 1 to 3. Just an angle.
The second to last thing I wrote, the inverse tan, that blue part. Give me a color. We can do this, and let's go like this. Okay, that'll work. So this blue part here, this blue part is just some theta. It's just an angle, because it's an inverse trig. So this is going to output an angle. So then whatever the angle is, we don't officially have the angle, but we have this right triangle trigonometry going on. So now we can just let this be that angle, and now we have, well, sine of that same angle is going to be 1 over the square root of 10, which is this. Let's so the green, the black and the stuff on the left was we were kind of being led astray. But then we said, because first we tried the unit circle, that didn't work. So then we tried right triangle, and that one did get us there. Let me check my result. Let me go to paper. I'm going to check my result really quickly. Quadrant 1, we got lucky there. Yeah, that's fine. Figure shows blah, 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 square root of 10. So root 10 over 10. Okay. But yeah, that one was right triangle trigonometry. Okay. So like if you try one technique, like if you try looking at the graph of the trig function and that doesn't get it, then maybe try unit circle. If the unit circle doesn't work, then try right triangle trigonometry. These are the main three techniques that we're kind of flowing between here. Okay. Find the exact value of this one. We have cosine of inverse sine of a negative 1/2. Let me do this one again. This is on the quiz? Okay. Do you have your quiz with you now?
Some of the stuff
Do you,
that was on the quiz was all like
wait.
S1.
You can work. You want to work on it while I teach? No. That's okay. That's okay. So let's see. Let's give this one a go. Let's give this one a go. Okay. So we'll just use this one. Can I delete this one? Trash. Yes. That's fine. That's fine. Let's go like this. Share. Notability. Okay, there it is. Okay. Come on. Man, everything is moving super slow today. Okay. So find the exact value of this one. So let's try the same technique, right? Since the right triangle trigonometry worked last time. Now, let's focus on the inverse sine. Let's go ahead and identify our domain and range. So if we consider sine of x, what was the restriction on the domain for sine? Negative 90 to 90. Square bracket. And then the range, I think we said was what? Negative 1 to 1. I don't know what that was. And then tell me about inverse sine of y. This is our range, and this is our domain. Okay. So if we look at inverse sine of a negative 1/2, is the negative 1/2 inside the domain of inverse sine? What's the domain of inverse sine? Negative 1 to 1. Is negative 1/2 between negative 1 to 1? Yeah, so this should be good. Okay. Is there sine of an angle that gives us a 1/2? Okay, let's focus on this. So, and let's use something a little bit more bold. So if we're doing inverse sine of a negative 1/2, right? Again, this equals, I'm going to do theta because I feel like it's a little bit easier to see than y. But I'm kind of using, sorry, it's easier to see than x. But I'm kind of using the x and the theta a little bit interchangeably. It's just a label. But the whole point is when we do inverse trig, it produces an angle. We have to be clear that it produces an angle. Again, this means sine of some angle equals a negative 1/2. Sine of 30. And what quadrant though? Is sine our x or is that our y? Sine is our y. And what quadrants is y negative? 3 and 4, right? So let me think about it. Did we miss one on the last one? Oh. So sine. Okay. So what? So if we had to choose between quadrant 3 and quadrant 4, which quadrant do we choose? So if sine is negative in quadrants 3 and 4, which quadrant do we have to choose for our discussion? Why did you say 4 over 3?
Because the cosine is
Mm-mm. What did you say? It is quadrant 4. I'm saying it's quadrant 4. Like, so we have sine of some angle gives us a negative value. Sine is our y coordinate. So y is negative in quadrants 3 and 4. All right. So now we have to say, okay, well, why will we choose one over the other? And then so we go back to our restrictions on sine and inverse sine. Our answer has to go from negative 90 to 90. So that's why the only between quadrants 3 and quadrant 4, the only one that's from negative 90 to 90 is quadrant 4. Does that make sense? Because like if this is 0 and we drop down by 90, quadrant 4 is over here, right? So that's inside our domain for inverse sine. But quadrant 3 is over here outside of our domain. Okay? So I know that's a little bit, is that okay? More or less? Okay. So we should have a quadrant 4 solution. Oh, you said 30, right? From the unit circle? That's a half. So then if we're 30 degrees away from the x-axis in quadrant 4, what angle is that? Theta should be equal to? So you said 30 degrees, right? What'd you say? Well, remember we said it has to be between negative 90 to 90. So I was about to say 330 as well. But if we drop down by 30, instead of 330, what's the coterminal angle? Negative 30, right? Because it's negative 90 to 90. So it's just to force it to kind of be in that range. So theta should be negative 30 degrees. Let me think if I did this right. Okay, so if theta is negative 30 degrees, so now what we want to do, let's choose this color. So cosine of, and let's be a little bit more consistent, cosine of inverse sine of a negative 1/2 should be equal to cosine of that new angle we just discovered. So then that's going to be cosine of negative 30. Anybody remember something we said last time when we take cosine of a negative? So it was very subtle. We kind of glanced over it. This is where I made a mistake in the last one, but I corrected it before we moved on. But because cosine is even, when we do cosine of negative 30, this is actually the same as cosine of 30 degrees. Even means that a function is symmetric about the y-axis. The definition of, I mean, there's more, but I'm just going to let that be for right now. Okay? So, but because cosine is even, we can essentially just lose the negative in this fashion. So now what's cosine of 130? Sorry, cosine of 30? Yeah, that sounds right, right? Square root of 3 over 2. I think this is okay. Only thing I can think that might be off is the plus or the minus. I'm trying to think if I'm missing anything. Okay, let me see. So if we go back, is this the one that we just did? Oh yeah. Theta is in quadrant 4. Okay. Cosine is our x. Yes. Okay. Is this a different one? Square root of 3 over 2. Is that what we did? No? Oh, we got it. All right. So I think they did this a little bit different. They put it in quadrant 4. They have their theta. And then once they had theta in quadrant 4, they were able to use Pythagorean theorem to find all the parts of the triangle. But it's the same kind of idea. So you've at least seen my style, and then you've seen like I think that's a lot more coherent, right? But, you know, you just kind of have to keep working it until it sinks in. Okay, I'm going to let that be. Let's try another one. Any questions here before we go forward? There should be questions.
Yeah.
Go ahead.
With
Which quadrant? Okay, let's. So that's a valid question, right? So where's the one we started? Is this the one? So this one, right? This is the one we just did. So when we focused on the inverse sine of negative 1/2, right? So we had sine of some angle gives us negative. Sine is our y. So then y is negative in quadrants 3 and 4, right? But because of the restriction on the domain of sine, the domain of inverse sine, the domain of sine was negative 90 to 90. So if this is 0, negative 90 is here, positive 90 is here, and we were trying to decide between quadrants 3 and 4. Quadrant 4 is the only one that's inside that domain. Yeah, it's yeah. For sine, yes. Okay. Is this okay? No. So, what part? Oh, the black and the green.
I mean, that I understand. It's and I understand that it's either 3 or 4 because the y is
Okay.
negative.
Okay.
It's when we're deciding which one is.
Yeah. So we're trying to. So for right now, the reason we're deciding quadrant 4 is because of that black domain. The top line there. I think you like.
I'm thinking because it's the domain. Domain is the x value.
Yeah.
So I'm thinking what we're talking about.
No. Don't think that way. I'm trying to think of how to say it simply. Give me a moment. So sine of some angle gives us a negative. So we had to decide. You kind of have to keep it on like the unit circle almost. That's the main focus. Unless you're looking at the graph of sine or cosine, then it kind of opens up. Let's just try to work another one, and hopefully it'll sink in. But I think you're almost there. Let's try another one. Okay. Sorry, my energy is so low. I told you like I'm running on fumes right now. Okay. So we asked to find the exact value of this one. Let's just try the same stuff. So, oh no, what did I hit? Is it frozen? Okay. So let's get a copy of this. Okay, so let's look here. There's that, and I'm just gonna crop. Okay. So now let's look at this one. Let's get our paper going. Find the exact value. So here's a copy of the original. So we have tan of inverse cosine of a negative 1/3, parentheses, square bracket. Okay. So what did we focus on first last time? What did we focus? Is this the same one or a different one?
It's a different one.
Okay.
So we're gonna back right there.
Okay. So the first thing we did last time was we identified our domain and range, right? To make sure that it fits, right? So what domain and range do we need to find? We start from the inside to the out. Okay. So the cosine, right? So if we look at cosine of x, what was the restriction on the domain for cosine?
0 to 180.
Okay, so that was 0 to 180. And the range for cosine was, okay. So then inverse cosine of y, this is our range, this is our domain. So when we look at inverse cosine of a negative 1/3, is that negative 1/3 between negative 1 to 1? Yes. Did we just do this one? So let's do a darker color. If we say inverse cosine, God bless you, of a negative 1/3, this equals some angle. Again, this means cosine of some angle negative 1/3, right? So cosine is that our x or our y? Our x. So when is x negative? Quadrants 2 and 3. If we had to choose between quadrants 2 and 3, which quadrant do we choose for our discussion? 2. Yeah, right? Because of the same kind of argument, right? What's the domain of cosine? 0 to 180, right? So if we had to decide between quadrants 2 and quadrant 3 is outside the domain of cosine, so we have to force that to be quadrant 2. All right. Okay. So if this is quadrant 2, all right. Okay. Okay. So let's try their technique. What is this? Oh, did we do it twice? Whatever. It doesn't matter. So let's do XY plane. And then like this. Sleeping. Like this. Okay. Oh. Okay, so we have this point in, what quadrant did we say? Quadrant 2? So I think it's done in this orientation. But this is our theta like that. Okay, that looks good. So then cosine of the angle is a negative 1/3. So here's a negative 1, here's a 3. So then what's the hypotenuse? I think it's going to be the square root of 10. I did it wrong? Okay, adjacent over hypotenuse. So what's the adjacent side here? I mean, we did that. Sorry, what's the opposite side? How are we going to find that? Okay. So it'll be negative 1 squared. Here, let's write the formula first. So we're using dang, I can't type today. A squared plus B squared equals to C squared. So if we find that missing side, say this is A, then it should be the case that what A squared plus negative 1 squared equals 3 squared. Okay? Mm-hmm. Okay, and then what? So then A equals plus. Wait a second. Yeah. 2 square. We said 2 root 2, right? Okay. Is it positive or negative? Yeah. Usually we do plus or minus.
But it's positive,
right? Because what quadrant are we in again? 2, right? And so this is our, what is this? This is our y value, right? So we go up, it's positive. Okay. Yeah, in the right triangle we saw for A.
Oh, it goes up and down.
Right. So that goes up and down. So we went up to quadrant 2 instead of down to quadrant 3. So I'm going to go with this one. Go ahead. It would have been negative. For these we do, right? Because of the restrictions on inverse trig functions. Okay, we got 2. Let me see. How did I do first? We said 2 times the square root of 2, quadrant 2. So theta is in quadrant 2. See, they did that. Now, usually when we do the right triangle trigonometry, we don't include the negative, but the idea is essentially there. Negative. Let me see something. Cosine. Oh, did we not finish? I don't think we finished. That was just cosine. Okay. Yeah. Sorry, that was just A. That's not the N. Okay. So right here, we're saying that A was 2 root 2. All right? But then we need to go back and find tan. Now they're asking us to do tan of that angle theta. So from here, what's the tan of theta? Tan is what over what? Tan is what? What over what? Tan. From SOHCAHTOA? Mm-hmm. SOHCAHTOA. What is tan? And TOA. SOHCAHTOA. What is TOA? Opposite over adjacent, right?
Oh, I didn't know you was asking that.
Yes. SOHCAHTOA, right? So tan of theta in this case. So what's opposite of theta? Okay. So this is going to be 2 root 2 divided by adjacent. -1, which is just the negative 2 root 2. So when we found 2 root 2 earlier, that was just A. But then we had to go back and use that complete right triangle to find tan of theta. All right? So then that explains where the negative 2 root 2 comes from. Because, yeah. Okay? So, again, I still recommend you definitely work on Pearson. They explain every question. Okay? Let me see what we're looking like. Oh, we're about halfway. What's the time? Okay. All right, we're going to let that be. Okay, so now let's talk about inverse secant, cosecant, and cotangent. For these, let's look at it. I'm going to let that be exact value of this. All right, so let me kind of explain that chart that was on the last slide, but I'm going to do it my own way. Okay, so if, I don't know, are we doing graphing here? I don't think we're doing graphing. Let's just kind of look at it for right now. We're actually to find the exact value of this. Inverse cosecant of -2. Inverse cosecant of -2. Let's give it a go. Right here. So we're asked to find inverse cosecant of -2. All right. Again, this is going to give us some angle. Again, this means cosecant of some angle equals -2. Is that okay? Is that okay? Now, what is cosecant? Cosecant is the reciprocal of sine, right? Okay. So sine, so cosecant is really 1 over sine equals -2. Okay. So we can kind of switch, right? So then we'll say sine of theta equals a -1 over 2. Let me see. Let me think about it. Inverse. So do we have an angle? So sine. So since we're doing, let's talk about sine again. So if we go back to sine of x, tell me about the restrictions on domain for sine. -90 to 90. God bless you. And then the range for sine. Okay. Now, let me think about this. So when we do inverse, let me think about it. Do we need that? Trying to lead you to the domain. Okay, so for me, the simplest way to visualize domain of secant, cosecant, and tangent is to look at the graphs. Did we talk about how to graph cosecant? Probably very briefly. Okay, let's look into that. We might be jumping ahead a little bit, but for me, once you get a sense of the graph, the rest of this it kind of becomes a lot more simple. So let's start with the graph of cosecant. Right, I think that's the one that we're working on. So if we're going to do the graph of cosecant, what we really do is graph sine. Yeah, just graph sine like normal, right? So if we're graphing sine, say this was 2, 3, 4. This was our 1, this was our -1, this is our 90, 180, 270. Yeah, and 360 is the last one. So let's graph sine, and let's do that in a different color. Let's graph sine of theta, right? Really quickly. So it goes like this, like this, this, and this. We connect it with a smooth curve and we get this. Now, when we go to do inverse cosecant, or when we go to do cosecant, cosecant theta, let me think about this. So when we look at the graphs of these, oh, you know what? What did I do wrong? Y'all notice something?
You can start from 0.
There it is. Okay. And let's kind of go ahead and jump to our, I told you I'm like sleepy. Okay. Let's fix this, this. And then let's go this way, -90, -180, -90, -180. All right, this one. So let's just graph the restricted one. So it would go here to here, and then we go back, like right here. And we'll have something like that, right? That's what the restriction imposed. So, oh, daggone it. I remember why I was doing that now. Let's go like this, copy. I'll just do it here. So now, let's look at the graph of, if that's sine, let's look at the graph of cosecant. So I'm gonna extend sine all the way like this, and like this. I'm just gonna extend it like this, and it continues going this way as well. So now when we go, so that's just the graph. This is just sine of x. So now when we go to graph cosecant, when you hear the phrase cosecant, what color comes to mind? Okay, I can't do yellow because it's too bright. I'll do this. This needs a little bit more contrast. I'm going to do orange. Okay. So when we go to do cosecant x, right? So all we did was graph sine like normal. The graph of cosecant, when we flip a 0, how does that appear on the graph?
Flip a 0?
Yeah. 0 is 0 over a number. When we go to it becomes undefined, right? So when we flip sine, all the zeros become asymptotes. This is an asymptote. This is an asymptote. Because when we flip 0, then it becomes undefined. And then it still passes through the max and the mins, right? So on this one, it's going to go like this. And then here we start close to the asymptote, pass through that point, and then finish close. Again, start close, pass through that point, finish close. I don't know what that last stroke was. Okay, totally sleeping. Right? So this is, the orange is what the graph of cosecant looks like. Right? But it has a similar restriction as sine. Since it's the reciprocal of sine, it has the similar restriction on sine. So the inverse trig looks something like the following. For inverse cosine, what was I about to do? Oh, so now, we have this asymptote here in the middle. And then it's going to kind of go like this. Is that okay? So the orange on the bottom, and let's go ahead and list out our restrictions. So now if we think about, what is this, cosecant x, the domain there, it goes from negative 90 to 90. What kind of grouping symbol does the 90s get?
Degree.
Parentheses or bracket?
Bracket.
Why are you saying bracket over parentheses?
Because with sign it was bracket, so it must be parentheses. Are they real? They real numbers, ain't they?
I know for infinity we use different symbols because that's not exact.
For infinity, you do use parentheses, right?
Okay, so here it is. So then cosecant, I gotta clean this up. So it does go from negative 90. I'm like a zombie, so I'm just trying to keep myself awake. That's like, I'm like dying. I'm about to break the rhythm real quick. Now, it has the same domain. It goes from negative 90 to 90, but we have to exclude something. What do we have to throw out? If we're looking at the graph of the orange. Yeah. Yeah, right? It's undefined at 0, right? That's what I was looking for. So we'd have to do it in the following way. Keep going. Okay, close. So negative 90 to 0, union 0 to, okay, 0 to 90. The 0 we don't include, but the 90 we do include. The 0 we don't include, the 90 we do include. And actually, the order is not right. Oh, no, that's fine. That was fine. Never mind. Okay, so that's the domain of cosecant. That's the restriction that we impose on. It's the same kind of argument as the sign. Once we have the graph, right? And then this is the range. This is the range. Okay, if we're looking at the orange, if we're looking at this graph here, how far down does this graph go?
Infinity.
To negative infinity up to what's that y value?
Infinity.
Okay. Let's go like this. I know, yeah, it's like, it feels really good. Okay. Let's go here. All right. So now, how far down does this go? To negative infinity, right? Okay, now when we trace it coming up, what y value does it stop at? Yeah, you said -1, right? And then what happens?
It goes back.
Where does it pick back up? Okay, so if we trace it from the range would be from the very bottom to the very top. Okay. So we said the range was negative infinity up to -1, and then union 1 to infinity. All right, so like this, we actually reach the -1 and the 1. I think that's it. That's the range. Okay, let's go back and answer the question because I'm like totally sleepy. Where are we? Let's go back here. Cosecant of 2. Okay, so now the whole point of that, we identify our domain and range including our restrictions on cosecant. So essentially, the domain of cosecant is essentially the same as the domain of sine, but we had to throw out the 0 because when we flipped the 0, it became undefined. And then the range went from negative infinity up to -1, and then it picked back up and it went from 1 to infinity. So we're asked to find inverse cosecant of 2. What's the domain of inverse cosecant? So if this is inverse inverse cosecant, this is our range, this is our domain. Okay. This equals to some theta. Again, this means cosecant theta 2. Did we do this one already?
The last one was -2.
I think we're some angle, okay? So that angle has to be from where to where? If we do cosecant of some angle, it has to be from basically the -90 to 90. Okay. I think we have to like, let me see. Okay. Oh, okay, I'm back. So now we have cosecant of theta equals 2. Cosecant is what? The
It's the reciprocal
of sine, right? So cosecant of theta equals 2. This is the same as 1 over sine of theta equals 2. So then sine of theta equals half. Do we have an angle? So sine of what angle gives us a half? Pi over 6. So it might appear as either 30 or pi over 6. Let me see, did we answer the question? Cosecant. Let me look at it really quickly. Do we have it here? Where'd it go? Not that one. Okay. Inverse cosecant of 2. I think we got it. So either 30 degrees or pi over 6. Okay, let's keep going. Pi over 6. Okay, what's the time? I need to pause for a moment. Okay, give me like 5 minutes.
Yeah,
Okay.
we all need
just
it, right?
take 5 minutes. I'm gonna kind of let this be. It's still gonna be like streaming or whatever, but let's just take 5 minutes. Hey Siri, set a timer for 5 minutes.
Your timer is set for 5 minutes.
No, because we're not really supposed to take a break, and like we can't really leave. So only leave if like you have to use the restroom. Okay. Oh, okay. And I think it's only supposed to be one person out at a time. I need the sunlight. It's like cold, it's rainy, it's overcast. I'm like, oh god.
I'm saying, I ain't getting no sleep.
I didn't sleep last night either. We just had the time change.
Right. It
Like,
seems like time's been going by fast.
Yeah, it's just all like, and then we keep like missing days. It's like completely throwing me off. I'm like, man.
What's going on?
How does time go back?
Huh?
How does time go back?
There is no way that time went back an hour and it get dark at like 5:30. That's crazy.
I know, right?
Time done went back like 3 hours. Had to, because there is no way. How? When you on the clock?
Okay. I had to go find myself some food. Okay. So let's keep it going. Go ahead. Let's see. What is that? What is that? All right. That was nice though, yeah. Okay, so we got this pi over 6. Yeah, I don't know. It's always like one extreme or another. All right, let's see kind of how the text explains it. So it says find the exact value of inverse cosecant of 2. So that means cosecant of some angle equals 2. So then let me see. So let theta equal inverse cosecant of 2. Then theta has to be between -90 to 90 and not include 0, which is what we said. Whose cosecant equals 2. Let's see. So we have theta equals inverse cosecant of 2. So cosecant of the angle is 2. The only theta in this interval. Oh yeah, we said that already. Okay, so we're gonna let that be. All right, we're gonna let that be. Use the calculator to evaluate inverse secant x, inverse cosecant. Okay, let's see it in action. So use a calculator to approximate each expression in radians rounded to 2 decimal places. So for instance, if we wanted to do inverse secant of 8 in the calculator, how would we do inverse secant of 8 in our calculator? What would we type in?
You would, mine has.
See, it's not there, right? Yeah, it's not there. Okay, so let's see how we would go about this. Can we change this and put it in a form where we can type it in?
Yeah, so secant is the reciprocal sine. No, cosine.
Cosine, right?
So can we do inverse cosine?
I thought it was like
Okay,
cosine over 1 something.
so let's do. I'm not liking this. Hang on. Let me clear my ink. I'll get a copy of this. No. Oof. Yeah, between the time change, like I'm like dying. I'm like, oh my god.
We're supposed to be getting some snow. Did y'all see that on the forecast?
Are you serious?
Yes.
When?
I don't know, but we supposed to be getting some.
Because if it's a
That's
day,
why I've been this
okay.
cold.
So
Oh God, they still gonna have hay bill. Light is gonna be going on.
so last time I was teaching, it was like this. It started like we were about to start class, and then the student was like, "Hey, Mr. Pfeiffer, it's snowing outside." I didn't even hesitate. I was like, "Guys, get out of here."
Right.
I let him go. I didn't ask for no permission. I was like, "Look, I'm gonna ask for forgiveness. I'm gonna ask for forgiveness and then ask for permission." So I was like, I just let him go, and I got out of there. And they eventually let everybody go. Oh shoot. Let me do that. I just deleted what I needed. Hang on. Give me 1 second. I'm like totally absent-minded right now. Let me share. Notability. Cancel.
Yes, stay home. Yes, I'm home. Just went grocery shopping too. Why? Huh? Yeah, we supposed to be getting some stuff.
Tonight?
I don't know about tonight, but we supposed to be getting some. This because that's why it's been that cold. This is why I've been so cold.
Okay. I don't need this one. Let's delete that one. Okay. Yeah, this. But yeah, when I was teaching at Morehouse, and it was like this, and it started snowing. I let the students go, and the inside I was like, "No, just get out of here, get home, get someplace safe," because Atlanta goes crazy. Like they lose their minds. And sure enough, I left, and it had just started. It had just started where we were, and so like I go to get on the highway, and like there was this like long line to get on the highway. I was like, that's not normal. So I just skipped it all together, and like I took the streets from here all the way home, and like I had to go real ginger because I definitely was doing a little bit of like Tokyo drifting a little bit, but I made it home. But had I gone on the highway, my car would have been stranded on the highway. Like my nephew was coming from the north side of town to way on the south side of town coming from school. They were all on the bus. The bus finally left the school like at like 4 in the afternoon. This is like hours after everybody else is gone. And that bus went on the highway and they got stuck. They didn't get off that highway until like 4 in the morning.
I hope they had some heat on there because no way.
They didn't. They eventually got off the bus and they got to like a Kroger's, and like when they got to the Kroger's, the manager was like, "Okay, y'all had a long whatever." He was like, "Just get whatever you want out of the grocery store." So, but I think they just got a bunch of candy, But but yeah. So I'm looking at. You saw me open the windows. I'm looking outside. And I think the light though. As soon as the light came in, I felt my energy rise. So, but it was natural light. I can't do artificial light. So anyway, let's get back to this. Okay, so now say we want to do inverse secant of 8 in our calculator. So let's look at this. Inverse secant of 8. This is going to be some angle, right? Again, this means secant of some angle equals 8, right? But what did we just do for secant or this kind of thing? Secant is the reciprocal of cosine. So this is the same as 1 over cosine of theta equal to 8. So then what can we conclude? Keep going. Okay, so switch them. So then we get cosine of theta equals 1 over 8. And then if we want that theta, we take the what on both sides?
The, I was gonna say, the cosine?
What kind of cosine?
Is it negative?
Inverse cosine.
Inverse cosine, right? If we take the inverse cosine of both sides, we'll get a phone call. If we take the inverse cosine of both sides, we'll get that theta equals inverse cosine of 1 by 8. This is what we would type in the calculator. And make sure that it is in what units? Radians, because it said express the result in radians. Yeah, in radians rounded to 2 decimal places. Can somebody tell me that result? Or actually, we can do it here. We have it right here, like that. Let's hit done. Let's go like this.
I got.
Hang on, let's type it in. It's looking good. Reload and refresh. Okay. Okay, so let's type, let me see the mode. We're already in radians. So we're going to do inverse cosine of, what is that, 1 by 8? What result did you get?
I got 1.44, 5.68.
Okay. Okay, so we got approximately, say, 2 decimal places. So what's that rounded to 2 decimal places?
1.45.
Okay, 1.45. That's approximately 1.45. Radians. Put RAD for radians. Okay. All right, where is it? Can you see it? Okay. Set your calculator to radians. Let theta be this, then secant is the same kind of argument. Now find theta cosine 1.45. You see it at the end? Oh, what time is it? I'm so dead. So dead. We get out. Yeah, that's okay. Oh, part B. Let's go ahead and do part B. And we can actually go back here. So that was A. Okay. So if that was A, say we were doing part B. We have inverse cosecant. Nope. Inverse cosecant of -2. We can set that equal to theta. What does it mean? Cosecant theta equals -2. Okay. So then what cosecant is the reciprocal of? So this means, see, yeah. I can't type. 1 over sine of theta equals a -2. So then sine of theta equals -1 over 2, right? That's a theta. So then, okay, I'm going to. So because sine is odd, we can actually do the following. This is actually the same as sine of negative theta equals a half, a positive 1/2. I just move the negative to the left and into the function. That's the definition of a function being odd. We can do this with sine and tangent and their reciprocal functions. All right, because sine is odd. Definition of a function being odd. Let me just write even and odd definitions really quickly here. So a function being even means that when we do f of -x, this is f of x. A function being, what color have I not used? That's going to clash. Let's do this. So a function being odd means that f of -x equals negative f of x. That's what a function being odd means. Okay, so it's like there's a negative in there. Okay. So because of that property, we can take the negative from the right and move it into the trig because this function is odd. So then if we bring it on home, now we get negative theta equals inverse sine of a half. And then so theta has to be negative inverse sine of a half. Let's see, how do we do? Oh, and then that's what we would type in the calculator. I guess we could have done the negative 1/2 too. I think that was a little bit overkill. Oh, no, wait. Yeah. I don't think we had to do that. We could have done, I'll just put as an alternative, theta is going to be inverse sine of a negative 1/2. Let's see, do we get the same results if we do those? I think they should be opposite signs.
So for the inverse sine, oh, that's positive. Oh, never mind. I got it. Negative 0.523598772. That's for inverse sine negative 1 2.
Is that not on the unit circle? Is it on the unit circle, right? You got a decimal? You got a negative? Okay, what result did you get it?
Negative 0.5235.
So two decimal places?
Just two?
Yeah.
Oh, negative 0.52.
Sine of what angle gives us a negative 1/2? Sine is our y, so we're probably in quadrant 4.
30.
Negative 30. Sine is our y, 1, 2, 3, 1. Negative 30 sounds good. Okay, let me try this one and see how do we do, because I'm like totally fogged out right now. I think we did that one. 5.2, right? Is that what you typed? Is that what you got? Okay. What about cotan? Can you use what's on the board and give cotan a go? Huh? I just at your you want me to do it on the board? You want to try this one? So the next one is inverse cotan of 1/5. You gonna do dry erase or the iPad? You want to work here? The markers, there are markers here. Okay, so inverse cotan of 1/5. If you feel like you got it, like if you can use the blue and the green to try. I'm moving away from the mic, so the mic is here, but I'm gonna step out for a minute. Yeah, so maybe you can use the blue and the green, and then see if you can do inverse cotan of 1/5. I'll be right back.
progress. So I decided to do the reciprocal, which was tan, and I got.
So you should do it the way that I did it though. So like,
So I'm on the right track, or
you got the idea. So just leave that up there, but start off by writing inverse cotan of 1 over 5, right?
yeah.
So just rewrite it. I mean, just start over. That's what I'm saying. Okay, so he's writing inverse cotan.
Is it just
Equals some angle equals theta. Okay, so then that means so cotan of that angle. Okay. So then cotan is a reciprocal of
tangent?
so remember you got to do 1 over. You're skipping a step. So cotan is 1 over tan. Okay. So then what happens? Okay. So okay, that looks good. So tan of theta equals 5. So then theta is going to be. If tan of theta equals 5.
Don't put that in the calculator.
If tan of theta equals 5. If tan of theta equals 5, then tell me how do we isolate theta? Take not the tan, but the inverse tan. If we do inverse tan, so theta's gonna be inverse tan of 5. Does that make sense?
Theta's gonna be inverse tan.
So let me show you which kind of makes sense. Almost. You're pretty much there, just the notation's a little off. So let me just kind of start from the beginning. What you have looks good. Inverse cotan of 1 by 5. This equals some angle. Again, this means cotan of some angle equals 1 by 5, right? So cotan is 1 over tan of some angle equals 1 by 5. Is that okay? So now if we flip both, tan of theta equals 1 by 5. If we want to solve for theta, solve for that angle, theta is going to be inverse tan of 1 by 5.
So it wouldn't be just 5?
Oh, did I not flip it?
No, you just let this one up.
Yeah, we need to flip both of them. So right here, flip. That's J, right? Okay.
And then we just
So then that's a calculator one. But we have to go through, and that was actually really good. That was good, yeah. We have to go through this to be able to type this in our calculator. Okay. Let me see the time. That's not right.
10:22 a.m.
Get out.
My a.m.
I know.
I got
Okay. Let's do one more. And let's try to get some practice. Okay. What result? Oh, what'd you get? 1.37. Huh? Okay, let's see. Okay, 1.37. Let's try that last one. Inverse cotan of a half. I'm going to work here. So inverse cotan of a half. So part D, we're asked to do inverse cotan of a half. Again, That's equal to some angle. Again, that means cotan of some angle equals, was it a negative 1/2? That's supposed to be a negative 1/2. Inverse cotan of a negative 1/2. So cotan of that angle equals a negative 1/2. So cotan is what? The reciprocal of? So this is going to be 1/tan equals a negative 1/2. And then what do we do with them both? Okay. That should be a theta to be consistent. So then we have this property. So then we flip them, we get tan to theta equals, what is that, -2? Is that okay? I think we're okay there. So then in our calculator, we would type theta equals inverse tan of -2. Did you get a number? You said 1.11? So like, okay, let's see, how do we do? I feel like we're missing something, but I'm gonna let it be for right now. Oh, back up. I thought so. Cotan. Okay, let's look at this explanation. I always kind of miss this one. Let theta be inverse cotan of a negative 1/2. Then cotan goes from 0 to pi. So cotan, let me think about it. Oh, the graphs of cotan. Yeah, cotan is restricted from 0 to 180. Let me think about it. So if theta equals inverse cotan of a negative 1/2, cotan of theta equals a negative 1/2. So now, I don't think we ever talked about the graph of inverse cotan. It's similar to the graph of tan. Sorry, we didn't talk about the graph of cotan, but it's similar to the graph of tan. But instead of going from -90 to 90, it parallels cosine. So it goes from 0 to 180 without the endpoints, and we exclude the 90 degrees. Let me think about it. Oh, so I want to say cotan is still the slope. I think we mentioned something like that before. Or we can say that this one is cosine over sine, but cotan is negative. So in what quadrants, do we have a negative slope between our point and the origin? Like if our x and our y are in quadrant 1, is that going to be a positive slope or negative slope? If it's in quadrant 2, is that positive or negative? If it's in quadrant 3, is it positive or negative? And quadrant 4 is negative, right? So the only two quadrants that have a negative slope are going to be quadrants 2 and quadrant 4. We choose quadrant 2 because of the restriction that we put on tangent and cosine, all right? So I can go deeper into that, but I'm just going to let that be for right now. I think we're at that point of diminishing returns. Okay. I think we got that one wrong. I'm trying to think about it. Okay. So, oh yeah. So did we finish it? Quadrant 2, use the right triangle to find cosine of theta. Did they say exact value? Inverse cosine, a negative root. So there was more that we had to do for that one. right? We had to force it to quadrant 2, and then use the right triangle trigonometry. Okay, I think I'm going to stop because I am like spent. Oh, that's the end anyway. So we'll let that one be. Okay, let's do this one really quickly. Is this the last one? Okay, yeah, let's do this one. It says write cosine of inverse cotangent of u as an algebraic expression containing u. Let's do this one really quickly. I think I can do it quick, and then we'll call it a day. You have to forgive me. I'm fighting to stay awake. I'm so like tired. I'm literally on like no sleep. I really think it's the time change. It's like I just could not go to sleep. No. Want to share, notability. Okay, import. Done. Done. Delete. Okay. Right here. Okay, this is it. So if we have cosine of inverse cotan of u, it says write this as an algebraic expression. Write this as an algebraic expression containing u. Oh, okay, okay. So now, let's look at this. So if we have inverse cotan of u, this equals some angle. Again, this means cotan of some angle equals u, right? Cotan is a reciprocal of tan, so we would say 1 over the tan of theta equals u. We probably could have stopped there, but let's keep going anyway. So then tan of theta equals 1 over u. So then what I'm going to do is my right triangle. I'm just going to draw a regular right triangle. I'm not going to put it in any quadrant for right now. Let's say this is my theta. This is positive. Everything is positive. Okay. So now, if we did tan of theta is 1 over u, where does the 1 go? Where does the u go? So from SOHCAHTOA. So what's my opposite? And what's my adjacent? So tell me about the hypotenuse. Okay. So I heard a squared plus b squared equals c squared. So the radius or the hypotenuse is going to be u squared plus 1 squared equals, I just call it r squared. So then the r is going to be, normally do plus or minus, but we're just going to take plus for this discussion. Square root of u squared plus 1. So this is u squared plus 1 square root. So now that we have our theta, if we go back, this is just saying find cosine. Now that we have all parts of that triangle, it's saying find cosine of that angle. So from that triangle on the right, what's cosine of that angle? From SOHCAHTOA, what's the chi? The hypotenuse is square root of u squared plus 1. Sorry. What did we just say? Under u. Is that okay? So it's like this. Let's kind of look and see how do we do it. We got u divided by the square root of u squared plus 1. They might make us rationalize that. You see it right there. 1 plus u squared. Yeah. Okay. That's a little intense. You have to forgive me. I am like a zombie. What's the time? Okay. So let's take like 15 minutes. Just, you can like work on your homework. Okay. And I can answer questions. Okay. So we did the best we could. You have to forgive me online. I'm like totally a zombie. I'm probably going to remake this video at some point. Okay. With that, we will end the session here. And from one beautiful mind to another, enjoy the rest of your day.